Alright, let's see if we're live. Alright. Reduce the volume. Let's put it back up. Okay, it is actually live. Maybe I'll just get started. I was just digging up this piece of code I wrote yesterday as a test for something unrelated, which was I wanted to see how easy it would be to write a basic reflection system using PDB parsing through the debug help API. And it turns out it's really easy. You can do it in like, how much code is this? 50 lines of code. So I guess while we're waiting, I can just go over it. I think we'll probably use some of this as a starting point for the profiler when we get to resolving code pointers to other stuff. But yeah, so this basically takes a PDB, loads it with debug help, traverses all the symbols and types, and then for the types, it does a well, not a completely recursive traversal, but it basically does enough of a traversal that for user-defined structs and unions and so on, you can get the size of the types, the names of the types, and very importantly for a reflection system, also the offsets within the parent of each type. So if I run this, it won't work. Do I have to rebuild it? That is odd. Oh, did I delete something from the solution? Oh, this is really odd. Let's just restart this. Oh, for the profiler? I guess maybe I'll release it, but it's hopefully, well, I think my purpose is more to be educational, but it should be useful, and we'll see how far we can get in a few days. Let's just see if this works now. That is weird. Why does it not want to rebuild? Oh, I think I know why. I was screwing around with this shit for reasons I do not know. Oh, it's not a header. Okay, here we go. What? Oh. But yeah, anyway, so just as an example before we get started, I guess a little bit to pass the time while people come along. Um, so what this basically does is it parses its own PDB, which is how you maybe would do it in a game, right? Where you're using the game itself to introspect. It's not a third-party program that you run separately. It could do it to itself. And so I have this user-defined struct called person, and if I search for person here, um, you can see this is all stuff I'm printing out. It identifies there's something called, it's a type called person. It's a struct union or class. It has 4 children, and those 4 children are this subtype relationship, 3 member variables, name, age, and parent. And you can see child name has offset 2, age offset 4 because we're in 32-bit, so it's 4 not 8, and parent is 8 rather than 16 again because we're 32-bit. But anyway, so I would definitely suggest if any one of you are going to write a reflection system, you should maybe do it this way if you're Windows only, because this is pretty darn simple. Just using this information right here, you have enough to do a variable tweaker, right, where you can display a little UI, almost basically like a debugger inside your game for tweaking variables. So anyway, something like this should be pretty good for that. All right, maybe I'll just get started. Honestly, some of this programming is not going to be the most glamorous, but let's get trucking. All right, so start a new project before I kicked off the stream. I'm calling it CCC. Very sleepy. Well, based on EGW. So for you guys that don't know Very Sleepy, I just downloaded it. I used to use it a lot. It's still useful for very sort of, for me at least, for very ad hoc programming. You can choose a process. I guess it works better if you have source. None of these are my own programs, so they won't have like full debug PDBs. But if even if you pick a system process, oh, and it's hung right now because I did something, which is a good example of why it's not great, which is that the way it does a lot of its things is basically using the debugger API, and there's a lot of ways it can get caught up. Although this is not, I mean, this is, I think, probably just a bug I ran into, although there are a lot of those that I've seen. VS, or is it Very Sleepy? But anyway, well, actually, I do want to show the basic features we want to replicate. To start, we're probably just going to do the raw sampling profile from EGW, and then next step will be symbolizing using PDBs. And once we have symbolized call stacks, then we can actually start organizing them to figure out the call stack relationships, inclusive, exclusive times, and all that stuff. So yeah, let's pick a process. Let's do a profile. I guess let's do something in here to force Chrome to do crap. And press stop, and you get a sampling profile, and you have all this data. As you can tell, well, I don't know if you can tell, but for the for whatever Chrome is doing, what we're seeing here is not super useful because most of the time is spent in waiting operations. So you really need to do a weight analysis, not a CPU sampling profile analysis. But anyway, you can get this. It has some ability to do drill downs. You can sort by inclusive, exclusive, all that typical stuff. If you choose a given function, you should typically see child calls if that is a function that calls another function. Like here, you can say, oh, this thing calls something else, like this one, and jumps there. So anyway, first order of business is really just to actually get the sampling profile data. And Very Sleepy uses a method that is essentially the way a debugger works, which is it attaches itself to the process it's profiling. So it has the ability to do certain privileged operations, and then it, on a timer, say 1,000 times a second or 100 times a second, depending on the sampling rate, it's going to essentially suspend all the threads, get their thread context. So I'll maybe show some of the APIs we're talking about this. We're not going to do it this way, but it's maybe good to know about just in case you ever want to do something like that. Or not resume thread, suspend thread. I guess I'll pull out all three APIs you need to do that sort of dumb method of sampling profiling. Suspend thread. If you have a handle to a thread, you can do this. It'll probably say something about privilege or permissions. Yeah, this function is primarily for debuggers. Maybe you don't need privileged access for this, but in any case, essentially what you do is you get the thread to quiet down so that the stack isn't changing. For example, if you want to do a sampling profile, you have to do an atomic snapshot of the stack and the register state. So step 1, suspend the threads of the process being profiled. Step 2, call get thread context. Get thread context. It can only be called on a suspended thread, I believe. Yeah, you have to suspend it first. The thread context is really just, it gives you, it fills out this struct of type context. Context, I'm just going to start filling this in while we're talking. Context is a processor-specific struct that basically contains the processor state. So I guess this is the x86 one. So you can see context is basically just a copy of all the like these are the segment registers, these are the debug registers, this is all the standard registers, R0 through R16, or RAX is the old name for R0. And this is the program counter, which if you're doing sampling profiling, this would be the thing you most care about, and all this other stuff. So yeah, so the basic process with the very sleepy method is suspend all the threads periodically, get their thread context, and then once you have their thread context, you can do a stack walk, and I think you can do stack walk with debug help with this function, which unfortunately, Microsoft made the decision to have the Visual Studio Compiler, at least I believe that's the case, because certainly most programs have this behavior, to have 64-bit programs by default elide the frame pointer, which means that generally, rather than using the frame pointer to walk the stack, which is the old reliable method, although it was never technically required even on 32-bit, but it was sort of a, you could get an extra fairly general purpose register back by using, for example, on GCC you could do femit frame pointer. You had something equivalent on Windows with MSVC, but it was not really a hugely valuable optimization. And generally speaking, I don't really believe in optimizations that make it impossible or very hard for you to debug things. Or debug them rather with simple tools. Because if you don't have the frame pointers, essentially what you need is the ability to always figure out, regardless of the state of the current stack pointer, where the frame is. And so typically what that means is, given the instruction pointer, you need to figure out an offset to the stack pointer to find the return address so you can traverse the call chain. And that's essentially what StackWalk64 does for you. So you can use this as an API, but this thing is dog slow. Although I think actually we won't be using it with ETW, so we don't have to use this shit with ETW. It'll give us the stack directly, which is nice. But I think Very Sleepy probably uses this method, since I know it uses debug help for most of its heavy lifting. But anyway, yeah, we're not going to use that method here. We're gonna use ETW, and ETW is the, I don't know when ETW became part of Windows. Maybe is it Vista? No, it must be sooner. Probably XP, right? But it's sort of gotten better and better and more useful in successive versions. Oh, actually since Windows 2000, so certainly XP. But anyway, ETW is the event tracing system for Windows. And if you guys know things like dtrace, which I guess was originally on Solaris, and was later ported to FreeBSD and Mac. And there's other things like that. EasyW is sort of trying to solve the same basic problem, which is you want to be able to have a lot of data throughout the system, all the way from the kernel through a bunch of user programs. Some of them are your own programs, some of them are just other programs that are running on your system. And to diagnose issues, performance issues, or just like actual incorrectness issues, you want to be able to instrument the system. And you want to be able to do this without like having to recompile all the programs to run in, or to restart them even, to run in some sort of instrumentation-oriented mode. So the idea behind really both eTrace, dtrace, and ETW is like, hey, there should be a way to expose a bunch of, provide a bunch of event data, but the app shouldn't have to spend CPU cycles providing it until someone is listening. And that's one of the basic ideas behind ETW and also behind dtrace. The big difference, if you guys know about dtrace, is that dtrace takes it a step further, because ETW is essentially just an event queuing system. If you want to do aggregation, so for example, suppose you wanted to compute the total time you're doing a profiler or something, or some other thing like that, and you wanted to compute the total time spent doing a certain thing, like maybe it's just total CPU time. With dtrace, you could actually run a little piece of script code that aggregates those numbers inside the kernel, so it never has to buffer up and queue up all those individual events, like context switches, maybe thread context switches. It can actually just sum that up and just jam on a single variable in there. Whereas with ETW, essentially the way that would work instead is it would have to queue up individual thread context switches as events, and then eventually they would get queued up and processed by user mode process. And so you can do all the same stuff, but sometimes if you want to produce a small result as a result of a lot of large data, so for example, maybe you're maybe what's an example? Like if you're doing a sampling profile and you want to do the time summing I mentioned, maybe if you wanted to do that with a really long run, like have it run for hours, if it had to generate all the event trace data, say on disk, it might be gigabytes upon gigabytes, like literally hundreds of gigabytes, that all gets added up into like a 4-byte number or something like that. But with the dtrace method, that sort of gets aggregated very close to where it's generated. With ETW, you just queue it up. That said, ETW still very, very powerful, and you can generate a lot of data. And you can use low priority I/O to stream it out to disk, so you can pick it up later and so on. So still extremely powerful and very pervasive in Windows. There's lots of ways to make use of the data. Anyway, so yeah, let's see. I've actually done some ETW stuff before. I'm not going to lie, the API is kind of a mess, and a lot of it is very poorly documented, and it's actually not an area where you're going to find a lot of good sample code out there. If you guys know Bruce Dawson's blog, he has a lot of articles on XPerf, which is an ETW-based tool, and he's written some wrapper tools for both XPerf and also later on for WPR and WP as a WPR UI. But the stuff he covers, even though it's extremely good and there's really nothing else like it out there, the stuff he covers is mostly at a high level. Like he doesn't actually talk about the low-level APIs you have to call if you're writing programs yourself. So if you go and look at Bruce's code, I think it's UI for ETW. This is really great. It does a bunch of sort of quality of life stuff for you. But it's still basically just shelling out to a bunch of existing programs. It doesn't actually use the APIs directly. So if you want to figure out how to use the APIs directly, you're mostly on your own. There's no great examples out there you can use as a template. But at one point I did sort of knock around and figure out a few things, so I'll try to use that as a starting point, which is this thing, which I'm just going to copy and paste in. So this is from a month ago. I was just fucking around with stuff. And so let's just try pasting this in here. See if that compiles. It does not. Don't I? Oh. All right, that seems to work. I'm generating in this temp directory. Oh, this machine does not have F, it has D. So if I go and run that, why do I keep typing ls? This is not Unix. If I go and run that, stop typing ls. If I go and run that, okay, it crashes. Oh, the reason it crashes is it needs to run with admin. I'm trying to remember how to run an admin with Commander, which I've just started using recently. Oh, it is running with admin, so why is it not succeeding then? Let's do the step through. I'll explain a bit about this a bit later. For now, I just want to make sure that it actually is still working. Okay, that did work. Okay, that seems to work. And that stops working. Okay, let's try that again. One thing that's worth mentioning already, I'll get into this shit more later, is that, like I said, ECW supports both kernel mode events, so things that are generated inside the kernel, like really low-level stuff, like context switches and when threads are deleted and created, and also profile data. But it also supports like custom app-defined events. And unfortunately, there's a little bit of a split in how you have to handle that data. Like the way you consume them is a little bit different. If you want to consume both at once in the same trace, typically you actually capture them separately and then merge them after the fact, which is sort of nasty. The other thing that's really crazy about the kernel traces, which is what you need for this profiling stuff we're about to do, is that it's exclusive. So only one process, or rather one consumer as it's called in ECW, only one consumer can actively have the handle to the kernel logger at a given time. Which, I mean, I guess maybe there's good reasons for it, but it's certainly a pain in the ass to deal with. But anyway, it also means that even if you just want to be the only one running, if there's an old trace, if for whatever reason your own program hung last time it ran, that trace session will still be open, and you actually, step one is always to kill that existing session. So that's what I do here. And then step two is to actually start the trace, and looks like that worked. And the next one is to grab stack data, and that actually worked. And now we do this. Oh, why is it? Okay. Well, we're going to do it differently. Fuck this console shit. It's because I have... Oh, actually, I guess it's... No, it shouldn't be it. I was going to say it's because I have a Win32 app rather than a console app, but that shouldn't matter for this. Oh, maybe because the console's not... Yeah, it's because the console hasn't been opened with this process. Anyway, we're going to do a good old message box. The way God intended. Press enter to stop trace. Information. Alright, let's try it again. Okay, here we go. This is the good shit. And then if you go to, I guess, the temp directory, yeah, there's now temp.etl, and it's not very big. Alright, so what it's doing right now, so now let me just walk through the code now that I know it still works, because it's months old and God knows what's happened to that code. But anyway, step one is sort of stupid. You have to have admin privileges. Well, not only do you need admin privileges in order to get in order to do a kernel trace session, you also need to explicitly ask for the token privilege to get that. Now, you can only get that token privilege if you have admin, but you still need to ask for it even if you are admin. I think just so you don't have accidental. It's just like a maybe least privilege kind of thing. Although I guess anyone can ask for it, so it doesn't really protect against much. If this thing already exists, we delete it. The reason for that is the code that tends to write out trace files will want to often append to the existing file, which is often how these things are used. And so if you actually want to overwrite it, I found this the easiest way to do it. Then you have to configure the trace properties. And one thing we have to do, like first off, this API, I think actually Casey Moratori wrote an article on how much he hated this API. There's some is it little menu API design? John Blow. I know it was on the witness blog. ETW. Oh yeah, this one. He wrote this article on the ETW API. Now, I think there's some stuff in there that kind of betrays the fact that maybe when he wrote it, he didn't quite understand everything that ETW is trying to do, and he was sort of tunnel visioning on his use case. And fair enough. But one thing that's definitely I think he complains about is this shit. The way you have to configure the buffer size is a little bit over the top, and there's a bunch of redundantly specified information. But anyway, basic idea is that the stuff you really care about setting up is you set the kernel events that you want to trace. So in my case, I set the profile one, which is sampling profile data. Image load. Image load is like you load a DLL. And the reason you need to know about that is if you want to figure out where an instruction pointer maps to, you need to know what memory range it fell into. So if you have an instruction pointer for some code from a loaded DLL, you need to be able to map it to that DLL, because once you know where it is relative to the DLL module base, then you can go and resolve it relative to its PDB debug info to actually figure out what function that thing lives in. This flag specifies you want thread data. So this tells you when threads are created and deleted. And you basically need to know that in order to have any information about, like when you get a profile event, it's going to refer to certain process IDs and thread IDs. And by grabbing these events, you actually have something to match those process and thread IDs against. Because keep in mind, those process and thread IDs are not guaranteed to be meaningful over time. So by the time you come around and actually process them, the threads and processes are not guaranteed to be alive anymore. So you can't just go and interrogate them live. So by grabbing this thread and process data at the capture time, you actually have enough context that when you process the trace after the fact, you can go and make sense of all those TIDs and PIDs. So that was one of them. This is the maximum file size, which is 100 megs. 100 megs is not as much as you might think, because you can capture a lot of data real fast with some of this stuff. Anyway, that's the main point. After that, like I said, you have to remember to close the existing session first if one is running. Then you have to start the trace. I remember that one of the things that Casey complained about in his article is that he said you had to both call start trace and open trace. I don't have an open trace here. We're going to write that in a bit. Open trace is what happens where the act of capturing the trace and sort of processing the trace are actually two separate actions when you're using a file to queue. I think Casey was trying to use the API in real-time mode, and in that case, you typically start tracing data at the same time you start processing data. And so he was complaining that they're two separate APIs. Actually, in the intended use case, which is normally not real-time mode, there's actually two different APIs for a good reason there. After you've started the trace, and apparently not before, I don't remember why I can only do this after, but in any case, you can do this trace set information call. We have to provide a GUID. I have a story about this GUID in a bit, but basically this lets you set the fact that you want stack trace data associated with each of the trace events, and we absolutely need that for a sampling profiler. So anyway, that was just like to quickly walk over some of this stuff. I'll start writing more code in a bit, and hopefully we'll get going. But basically what we have right here is already enough to cap, and this is really how awesome ETW is that with just this code, which is not a lot, figuring out how to write this code is a different question. But once you have it, it's not a lot of code, and this actually gives you all the data already that you need to reconstruct, all the call stacks and whatnot. So since I don't want to wait to write a full program in order to make sense of this data, I just wanted to show you some tools that you can use to kind of interrogate these generated files. Which, I guess Xperf is one of them. Um, so if you go to temp, we have this temp ETL file. If you use Xperf, I'm trying to remember what the thing is called. There's a way you can. Let's see if I remember. There's a way you can convert a binary ETL file to sort of a text-readable equivalent, which is good just for making sure that the data is in there that you expect. I think it's -I and -O maybe. Of course, this is probably not even fucking documented, so that's great. Let's just try it. Xperf, and then okay, that worked. Nope, it did not because this thing is not very big. Xperf -I. Oh, you need an action. The name of the action. Do I really need to specify? I didn't think I needed to do that, but I guess we can do it. No, that's not outputting dick. Okay, let's I guess drop this in so Visual Studio will auto reload it. Okay, so this only had the header. Do I have WPR installed? WPR UI. No. Windows performance. Yeah. Let me just try to open this ETL file here to see if that works. If it's just me and my Xperf skills are out of date. Yeah, it doesn't look like this thing has anything. Did I really not capture that data? Guess let's try running it again. How do you create new tabs in this thing? Boom, boom, boom. Okay. Okay, so that was a 10 megabyte ETL file. That looks better. I guess let's try again. Maybe I botched it the first time. Okay, here we go. It's actually doing shit. That's what I like to see. This is where we find out how bad Visual Studio is for parsing large text files. Okay, so now we're in business. All right, let me just get a quick sip. But anyway, like I said, the way I used XPerf here basically just does a text serialization of the binary data with a little bit of cleanup, but not by much. So let's just go over some of the interesting stuff here. The header itself contains a bunch of metadata about the different events that occur in here. So let's try to find some stuff here. So for example, the sampled profile event, you can see that the different fields are timestamp, PID, thread ID, program counter, which is the instruction pointer, CPU number, thread start image, and function. I think this is only when this is an example of something that's not actually in the file, but where XPerf, if it has the data, will try to symbolize, but it doesn't. And we'll have a count here. So anyway, this is just like sort of the different columns of these different event types. We'll go over these, I guess, as we get further. But so one interesting thing is, I think I mentioned in passing that, oh, you can't see what's going on? Does it not have full screen? That's interesting. Let me just check OBS. Oh, you do have, so when I do this, oh, that's weird. This doesn't show up. I'm using Commander with the okay, I'll use another console. Oh well. I've noticed that whatever method OBS uses to capture stuff. Okay, I'm sorry about that. I've noticed a few other cases where when I was doing some debugging and I was using the mouse hover thing to get info on variables, variable expressions, it uses these sort of hover tooltips UI things, and they were not showing up in the stream either. So people must have been thinking I was just staring at the screen, which is hilarious. But anyway, so let me make sure I don't use Commander. Thanks for catching that. All right. So let me just replicate what I was doing now that you can actually see what the fuck I'm typing in the console. When I run my ECW tracer, it generates this temp.etl file. ETL stands for event trace log, which is basically just a binary concatenation of a bunch of records with a certain layout. And we're going to basically parse those ourselves using some built-in APIs. But before we get there, I just want to show you guys what is actually in there semantically, so you know what we're in for. This will also just be a useful sanity check if I make mistakes when I do my own kind of parser or consumer of that. But anyway, yeah. So if we delete this thing, so now I guess it'll be empty or not. That's weird. It doesn't reload that when you delete it. If you do xperf -i and then the ETL file -o temp.txt, it basically does a text serialization of the ETL file. And now we have to wait for Visual Studio to open a 10 meg text file. But yeah, so that's how you do it. Too small for me. Now you're just trolling me. How is it doing anything while it's sitting on that? So it's actually it's asynchronous. It's a kernel tracer. So basically what this is doing is I'm setting up a set of events that I have interest in. In this case, it's this because they're kernel events. They're not based on these. Normally, you specify GUIDs, or there's also GUIDs to back these, but the way you configure these is just using a bitmask. You set which ones you're interested in. You say where you want it to write them. In this case, I'm writing to a file on disk, but you could also write it to a sort of a real-time callback, basically. And then I just say go, and then the kernel does its thing. So this is all inside the kernel, so I'm not really in the loop. And so even though I'm blocking, the thing is just churning away, generating crap in the background. So anyway, that's why it actually works. And this is also grabbing profile data for the whole system. So that's pretty cool. It's a whole system profiler. You can filter stuff down, but the default is always to get everything, which is really good because it kind of means that all the data is there if you want it. You don't like, for example, the way that Very Sleepy does its profiling. It's already really slow even for one process. But if you wanted to do whole system processing with Very Sleepy, I mean, the whole system would just shit itself. It would not be workable, I think. I haven't tried, but given that it doesn't work great even for one process, I wouldn't predict good things of trying to do it for the whole system. But anyway, so yeah, this is the starting point. I'm probably just gonna. Oh, I guess I should maybe. Let me just. This is some older code here. Um, I'll just do it the way I do it nowadays, which is this. This is my standard assert macro nowadays. Okay, why do I have two? That's because I copied some shit. Don't need standard I/O. All right. Got it building again. I don't know what I was doing with these weird brackets. That must have been a weird phase I was going through. All right. And I don't know what I was doing with auto. That is disgusting. Especially with these things. I'm always worried with... okay, so these are bulls. Why am I zeroing? Oh, it's because in that case it's actually... I guess that's okay. Alright, let's see. This one... This is a U long. I guess this is a U long as well. Sorry for just having to do this cleanup. I just don't want to go along with this old crap if it doesn't make sense. Alright, still works. Yeah, I actually explained earlier exactly how Very Sleepy does it with suspend thread, get thread context, resume thread. So yeah, it's very invasive. I don't know if this is everyone that gets this, but I also get weird hangs, like sometimes permanent hangs, but sometimes also weird sort of like 30-second hangs that eventually resolve themselves. So yeah, that whole process isn't is I think it's I mean it's useful for some things. I think nowadays with modern Windows, there's no real reason to use it. So we're going to use this method instead. So okay, I think this is roughly good to get started. So probably I'm just going to actually keep this code, and I'm just going to now start doing some consumption. Oh, let's just look at the text file again because I didn't get very far. So the sampling profile events are these things called sample profile. So like I said, it's good to look at this thing just to make sense of it. You can also see, by the way, that it's already tried to do some symbolization. That's not something that's actually in the ETL file. That's something that it did itself based on, all the module data, image load events it had in there. Like if actually, like, I guess I can show you. So you see right now on these lines, no, I guess no, it doesn't actually have. Well, it has image load data, so it actually knows what. Yeah, should be enough. This is also early on in the process where it's still catching up. Eventually it should get you just mostly sample profile data. Yeah, this is a good example of what it looks like. Okay, there's a lot of initial sort of I want to just mention one thing because this is a really nice design trick you can use if you're ever writing this sort of event-based system. There's a tendency for event-based systems to be edge-based. So the events signify when something changed. So for example, maybe a thread was created or deleted. Those would be natural events. But that doesn't necessarily let you join in the middle and know the current state of things. Do you see what I'm saying? So that would tell you what things are live and die after you started listening if you only get told about thread create and delete events. But typically you need to know the current state from the time you start listening. Otherwise, you can't really apply those deltas in order to infer the current state at various points in the time through the trace. So one thing that ETW does is it has these, I think they're called DC events. It stands for data collection, where there's like special event there, like aside from the basic, like for example here you have p start and p end. These are the events that say a process started and a process ended. But at the beginning of a session you're also going to get these sort of mirror versions called well, I guess the main one is the DC start one, which basically says, well, let's search for one. It basically says here are the actual processes that are currently running, like at the time it started. So this way it kind of catches you up to the current state of the processes as you're starting to run. So you can see these are all the processes that were, this is a good way. You can see this is basically like the task manager view of like what shit was running when I started my trace. And so after parsing all these DC events, I can then, if I see that a process dies, I effectively match it up to whatever, whichever one of those processes was alive. So this way, I'm never going to see like a process end event for something that I didn't know about. It's always going to be relative to that baseline from the DC events. So this is like a nice trick you can use yourself if you're ever if you're ever doing this sort of event-based system that's mostly oriented around edge triggering, but you also want to be able to start in the middle, as it were, you can just have sort of separate special events that are only emitted when someone starts listening that kind of catch you up to the current state. Were those stack entries on context switch or whenever the timer interrupt fires or what? This is based on I believe just well, actually, context switch is separate. This is based on the timer. So I can't remember if I explicitly configured the timer here. There's a way to set it with this function. I believe the default rate is 1,000 times a second. But anyway, no, it's only, so we can talk about that. But it's only when the timer fires. On context switches, there's a separate event type, which is actually easy to get. You literally just add another flag, like context, or is it CS switch? Okay, I don't know why. Event trace flag CS C switch. Actually, let's do that just to show you, because I mean, I think one of the cool things about this system is how much data is just there. It's right there for you to take and do cool things with, right? Like how cool is that? But let me just, yeah, so let's do this. And now we're tracing some shit, and I'm like, oh, I'm browsing the web, guys, and I'm doing this, and then I'm going back and I'm pressing this button. Okay. So we have a 36 meg ETL file. So you can see even just from like 10 seconds, that's quite a lot of data, which means we're now going to get like a 100 meg text file. And I would like to see what Visual Studio does with that thing. That's the wrong project. Did I really? Oh, here we go. Oh yeah, Visual Studio is hung even trying to load that fucking text file. Let's give it a while to catch up. I should probably not use Visual Studio to trail those files, should I? Oh, here we go. It's there. It's just oh. No, it's fine. Let's see if this thing actually... I don't know if this actually reloaded or not. Let's see if there's context switch events. There are. So now there's C-switch events. We didn't have those before. And now if you search for C-switch, I'm searching. It's just really slow. You can see here it's switched, I guess, away from DevEnv, which is Visual Studio. Here there's a context switch, and you can see the state of the process. And I believe it shows the... I can't remember what all those columns are, but you can kind of get an idea that you get a bunch of data from this. I'm going to turn these off because we don't care about them for now. But yeah, so I mean, again, like I said, like it's incredible the wealth of data it's collecting, and it's not collecting these by default, but it's kind of ready to collect them if you ask for them. So yeah, that's super cool. Let's just remove those and go back to our original set of events, and then catch some stuff and rerun this thing. This file's getting bigger and bigger. I have a suspicion that it's actually not deleting itself. Yep. Let's take a look. Oh, I think it's because maybe it's still spooling out the data. What is the name of the sysutils utility that shows you show sysinternals, show what process has file open? Is it Pocket Explorer? Oh yeah, handle. That's the one. Whoa, calm down there. WPA, oh, I see. God, I should probably assert on that. So what was happening is when I was testing earlier, I had that ETL file open, and so the delete wasn't succeeding, and so it was doing append only every time I ran. So it was just getting bigger and bigger. All right, let's do some capture here. All right, edmegs. That's a little more reasonable. More reasonable, but apparently not reasonable enough for Visual Studio. There we go. Yeah, you can use progmon. I think handle was actually the one. I like the command line one since you can just type a full path in there. But anyway, yeah. So you can get context switches. You can get all this stuff. These DC. So let me just rehearse. You get all this data. The DC events catch you up to the current state of things. And the main thing we care about for sampling profiling is a sample profile event. Let me just go further in the file. So typically a sampled profile event, you're going to, I turned on stack traces. If you didn't have stack traces on, you wouldn't get any of these stack events. You would only get the sampled profile event itself, which would have the instruction pointer of where the thing was sampled to be, and also data about what process it was, what was the process ID, and so on. But if you turn on stack traces, it will actually do a stack walk at the time this happened. Now the reason it kind of has to do the stack walk then and there, because by the time you get around to processing the profile data in the ETL file, it's not as if the stack will be there anymore. So it really has to do that as sort of in line. So all that data is in there. All right. So this is the two things we're really going to focus on for now, just to get the data. Eventually, we have to start slicing it by threads and processes. But for now, let's try to get the sample profile events and then the stack events. And now we get to the part I haven't done anything with before, which is actually, well, it's not true I haven't done anything, but I haven't done this section before for sure. So we'll have to figure that out. I do know that everything starts with OpenTrace. So let's try that. Any other questions so far? Like so far, this has really just been an overview of ETW at a very high level, and what kind of data is in there and how you can capture it yourself if you're so inclined. But hopefully it will start getting a little more interesting now. Although that is already pretty interesting. There's a bunch of tools, by the way, if you guys don't know, that work with this ETW data and the ETL files. The big one was the one I sort of showed a little bit earlier, which was WPA. And Bruce Dawson's UI for ETW is essentially a front end for Xperf for capturing, and then calling out to WPA to actually sort of visualize the data. But there's a bunch. There's an increasing number of Microsoft tools that use ETW. For example, the profiler built into Visual Studio, I believe, as far as I know, uses ETW for its sampling profiles. There's a really cool tool called Visual Studio Concurrency Visualizer that someone told me about, and I've since looked into more. Essentially gives you all this kind of context switch and data for threads and processes that's in this that you can kind of already see in that trace I did is there, but it shows it in a way that's kind of that's more intuitive and actionable to sort of normal programmers. Like it will kind of let you easily visualize when there's uneven workload and when there's sort of too many threads relative to cores, like, or too many runnable threads relative to the number of cores, and when you're not doing good I/O, and when you have, like, you know, lock convoys, when one thing unlocks, then waits on another lock, then waits on another lock, and so on. But yeah, so there's an increasing number of tools built around this. So I suggest you definitely start kind of, maybe this will be a good taste of that to do this thing. All right. Okay, OpenTrace. So OpenTrace, I believe, let's see, event trace log file. So you have to So we have to fill in one of these guys, specifies the source from which to consume events, and the callback. Right, so I said we're going to parse this ETL file. We're not going to do it directly, though. The way it basically works is that you provide the file to you provide the file to parse, and you provide a callback, and your callback will get callback for every event in that file. But I think I've never tried, but it should be really easy to write this yourself, because really the main thing it does is it just looks at the length field in the header of each record in the ETL file, and it gives you a pointer. It reads that record in, it gives you a pointer to that, and then it skips to the next record. I don't think it does much more than that, honestly, but we are going to do it this way. Okay, so we have to gonna null this out. Let's see. We need the log file name, and I think we already have that. What did I call that? Trace log path. We need the logger name. Okay, so logger name is not required, so we're just going to skip that field. Current time, and this is on output. This is one of these interesting windows to API patterns where you provide a partially filled in struct as input, and then it gets sort of auto-completed, if you will, or completed. Some of the fields get written on output, which means you don't need sort of separate input and output structs. It's kind of a convenient API trick. Process trace mode. Process trait mode, event record. If you want to receive events in the new event record format to receive, you must specify a callback in the event record. If you do not, you receive. Okay, so maybe I'll use this. So if you do not want the time to convert it to system types, leave this in the proper resolution. Are these flags or modes? Okay, there are modes. So I believe this is the one I want. process trace mode. Current event on output contains the last event processed, and this is the header. So I believe this header, by the way, just for those keeping track, this header is basically the binary encoding of the shit I saw up here. Since it says begin header, end header, that seems like a reasonable guess. And then the buffer callback. For each event, for each buffer, ETW flushes after it delivers. Okay, so this is optional, so I don't have to fill this in. Okay, so then there's the event callback. Okay, this is the one I want, the event record callback, because that's what I specified. So we're going to make one of those, event record callback. In our case, it will be an event. It will be a kernel Dogger session. This is like a user data pointer for my callback. In this simple case, I don't need that for sure. And I don't care about that. So it's mostly about this thing. Well, that's interesting. What about the callback? Okay. LP vstir. Why is that not working? Pointer to vstir. LP star. Okay, it's just the const thing. Okay, so that already works, and I guess we have to do open trace and close trace. I guess we get a trace handle from this. Oh, and we already had a trace handle, so we can just reuse it. I'm actually going to put this stuff in a separate function. So this will be record trace. And this will be process trace. I'm just going to provide these globals. Well, refactored later. Okay, let's call this start recording trace. And then we'll have finish recording trace. this should be like elevate privilege. Yeah, this is a long, so shouldn't. Trace handle is where session properties. I don't believe that's actually required when you have the trace handle. What's the signature? Yeah, I don't believe that's required. I guess we'll find out. So this failed to start. I almost guarantee you that the specified module cannot be found. That doesn't sound right. Oh, so we forgot to elevate privilege, which makes sense. Okay, doing some stuff, press enter. Okay, and then it fails, and I think that's probably because I don't specify this. So I should do that. Okay, doing some stuff. Okay, that looks a little bit anemic. Just get some more stuff. Okay, that was better. That's probably too much, actually. I don't think well, let's try again. I think actually what's happening when it's really small is it actually not deleting? What the fuck, why is it so big all of a sudden? Really quick. Okay. Okay, 6 megs. We can handle 6 megs. Alright. Love your math. Yeah, this is going to be archived. Alright, I open the trace. Where was the callback? Callback was here. Okay, so I should start doing some stuff with it. This thing is, I guess, a little bit of a different trace handle. This is like the record handle. And this is the trace process handle. Okay, so let's try that now. I guess, well, let's try to get some basic data from this thing. I think you should be able to get the header at least without parsing anything crazy. Yeah, let's just get the timestamps and right, so actually before I do that, let me just quickly test this function actually works. Output debug f number string Unicode string 123 hello world. Oh, I didn't actually call output debug string. All right, that worked. I guess let's print some stuff. Set timestamp, which I guess is a 64-bit thing. Event property, kernel timestamp. What property is this? Large integer quad part, I guess. Event record does not have an. Okay, so this is right because this is all actually just. These records are actually just like raw data on disk. So one thing you're going to find is sometimes you'll find sort of internal pointers, but they're always going to. I mean, the data itself is all in line. Okay, let's see if that actually does anything. Okay, so we do some stuff and then we press enter. And we didn't get anything. I should probably verify that this actually did anything. Overlapped I/O is in progress. I see. So the problem is the file has not been written. Will we need the log file anymore? You can do real-time logging, and maybe I'll do that later. But the nice thing about using the disk, there's actually, from what I recall, there's actually ways to do disk-based logging that just uses the disk buffer essentially just as an extended memory buffer, but it's still sort of trying to do it as quickly as possible. But I think using the disk is kind of nice to decouple things because otherwise there's, you know, a lot of the data it has to push over. If you can't process it fast enough, then it has you lose data and stuff like that. By going to the disk, it's a little bit easier. But the same basic API is used for both cases. It's just that the real-time API I think is a little bit more awkward. But maybe we can try that in a bit. Yeah, maybe we should just do that. Maybe we should just do real-time record. Open trace, so overlap IO in progress. I assume it's just like we have to somehow, there's like an IO event we have to wait for. Wait for log to be written. Maybe I'll just use there's Casey's thing. Yeah, maybe we'll just use real-time logging. Real-time consumer. Actually, I kind of want the file just because I want to be able to see whether I want to be able to decouple the two steps so that I can replicate like for example, suppose my processing function is buggy. I want to be able to do the repeated runs over the same input data. And this way I can also use xperf to sort of do an A/B comparison between my interpretation and xperf's interpretation. So I think even if only for development, we should keep it to log files, and then afterwards we can look at making it a real-time consumer once I'm confident that it works properly. Okay, so let me just do the time-honored method of multiprocessor synchronization. Actually, let me just do that. So the tracing. So that's still in progress. But yeah, you can see it. I was seeing this before where I wonder if I've neglected some sort of flush. Yeah, this thing is not getting bigger on disk. Well, let's use good old MSDN. Oh, I see. Open. So I find more trace sessions. Okay, so it looks like I have to call process it once. So open is just the preparation function. Process trace actually does all the things. So maybe it's actually working. Maybe I was just looking at errors and they're not actually errors. Let's see here. So process trace. Okay, I should probably not call it process trace then. That's a little bit ambiguous. I'll call it profile for this. Start recording profile. Finish recording profile. Process profile. And this will be process trace, and we'll just have to this will be have to pass an array of handles, so I just provide this and provide a handle count of 1. Start time, end time, this is optional. I assume if I just do this, it will work. Okay, so that actually worked. And these look monotone, so I have reasonable confidence that these are actually timestamps. Okay, so the next step is to actually figure out which events are which. let's go look at that record. So there's a header which has a fixed length. There's this thing which is not part of the original on-disk format clearly. And then there's this stuff here, like standard user data. And I believe this stuff is sort of past the, basically past the thing. Oh, okay, it just points to it directly, so that's pretty easy. The size and bytes. The event header should have the GUIDs for the event types. Probably in the event descriptor. Doesn't look like, I mean, there's this event ID, but that's a short, so it can't be a GUID. There's a long, that's a bit mask. Oh, provider, I see. So provider ID is the overall category, and then those event IDs are like the subcategories. So provider ID, okay, so we need to go find provider IDs for sample profile. And I think I probably, yeah, so it's already from the perf info provider. Thank you, Microsoft. I do not give a damn. It's already from that, so probably the filtering should be on, what was it? Provider ID. What type is that? It's a GUID. Okay, I already found this somewhere. That should be a GUID as well, right? Is there a macro for comparing GUIDs, or do I have to write that myself? I mean, not that it's very hard, but that seems kind of stupid. Compare GUIDs. Okay. If this is in some sort of fucking MFC library, I'm going to kill someone. Well, it's an OLE32, so it actually is a stupid COM library. Holy shit. Well, let's be lazy. Provider ID. Okay, so this should be just the perf info provider. By the way, one thing that drives me nuts about the documentation for the different kernel events in, let's see if anyone's wrote. One thing that drives me nuts about the different kernel events in the documentation on MSDN is that it's all this fucking, like, look at this shit. I just want to count the ways that this is either wrong or confusing. First off, the way they use fucking C# as far as I can tell. It's either C# or something, or maybe C++, CLI or whatever. It's basically C#. To document all the data layout, and they use like fucking .NET attributes to document it. So at one point I was trying to find where the GUID macros were for this shit, and I remember having to Google, like somehow found this page, then I wanted to Google this thing, and it's like, oh, this is also awesome. Oh, there's a page called NT kernel logger constants. And this is where I found that perfinfo GUID definition originally. Like, this is so non-discoverable, it's ridiculous. But anyway, then you go and look at this shit, and it uses inheritance to indicate. So basically, this is the provider. So they have an empty base class, which is an abomination unto itself, to indicate that this is a provider, and the provider has this GUID. And then the individual events provided by the provider are subclasses as a way of indicating that sort of. It's not really a parental relationship. It's just like, this is an event provided by this fucking provider. And then in order to find out what the event type is, again, they use this stuff. And here's the other kicker. Look at these data types. Why the fuck is an instruction pointer uint32? Spoiler, they're not. ETW has this thing where, as you'd probably expect, depending on whether the system that recorded the trace is a 32-bit or 64-bit machines, pointer types will be a different size. And in fact, that's encoded in the header of the ETL file. But good luck finding that out just reading this. Now, when you're dealing with something, I mean, it does have these qualifiers that say pointers, but there's really nothing in the docs themselves to indicate that, you know, for example, the thread ID is not the same uint32 as the instruction pointer. And the other thing is, like, so now our next job is going to be turning this thing into a C struct so we can easily extract this data. But like, who knows what the packing is of this shit relative to standard C packing? I mean, I hope it's going to work out, but I don't know. So good stuff. Good stuff, Microsoft. But anyway, so let's try to get that sample profile. So yeah, so if we have that provider GUID matched, and then in theory we should be able to. Actually, let me just copy this thing over here and start roughing some stuff in. I'm just going to leave this, I guess. So this is going to be instruction pointer. I think this is a genuine, like, int32, and this is a genuine thing like that. Let's see if... Okay. Is the event type a top level field? It is not. So I guess it's in here. Maybe it's this ID. God only knows. But let's suppose it's this ID. Yeah, you can see up here, by the way, I specified it this way. Let's go and read that the event record, or the event property. Like, I assume it's this thing. But why? Like, why is it called an ID in one place and a type in the other? Jesus, guys. All right. Let's do this. Okay, so that didn't match anything. Maybe I'll just print. Oh, is there another thing? God, not XML. I'm done. Am I missing something? So this is the GUID for the provider. Maybe I should just log log a bunch of these fields on the chance that any of them are useful. So let's log, I guess, a couple of these. Okay. So the opcode is the type. We should make an enum with some of these things. We call this. Actually, I don't. Okay, let's just do it this way. Okay, that looks good. So I guess the next step is maybe doing some casts. I think for most of these, so the event records are fairly self-descriptive. Like, it has the user data length. So worst case, even if you don't know what data you're dealing with, you can at least skip it in the file. Which means that I think the ETW parser doesn't really have to know what it's dealing with. It just passes it on to the user. If the user knows how to parse it, great for the user. Otherwise, it'll just truck along to the next record. But I think in this case, because I'm switching on a very specific type, I should just be able to take the I should just be able to do something like this. Let's see. I guess if we print this in hex, and we'll see what happens. What? Switch expression of type. Oh. Okay. Okay. Da, 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 da. Okay, this looks promising. This is definitely just looking at the corresponding. Yeah. This looks like instruction pointers. Yep. So, what was the second flag I printed? This was the thread ID. And you can also see these are recurring between some of the traces, even though the instruction pointer between here and here changes. The thread ID is the same, so these are like samples from the same thread. And then the last one was the count. I'm actually not sure. Is the count incrementing? So the count goes down from this to this. On the other hand, the counts overall are sort of in the same range. I wonder what that means. Oh, it says not used. I mean, okay. That's not what it looks like. Yeah, we let's see. So, right, earlier we dumped timestamps for all the events we caught. Now I'm actually at the point where based on these GUIDs, I am finding just the events that are representing, you know, like timer interrupts along with, you know, the getting the instruction pointer from that and the thread that happened on. So already we have now instruction pointers and correlated thread IDs, and so between these two things, in theory, we already have a lot of data. We don't have stacks, which is the next step, but we have the top level instruction pointer and the associated threads. So if after the fact we could basically bucket these on threads, and because we know these samples are happening at a fixed rate, we can say that, you know, we can basically look at the ratio of different threads receiving different samples to say, hey, this thread was running 90% of the time or 10% of the time. So we could already do that right here, just using this data without any further work. So, yeah. Okay, so let's just kill this count flag, which doesn't seem to do anything useful. So I think the next step is grabbing stack crap. I believe the way Stackwalk stuff works is weird because, like I said, they're not part of the they're not part of the event itself. They're sort of like if there is a stack event immediately following another event or something like that, it's considered associated. Oh, it's not Stackwalk. What is it called? ETW stack walk. I think this one, maybe. No, that's for the CLR. Fuck that shit. I think it's actually under this general kernel trace categories. Maybe we should just go and look there. Why am I not getting the usual side panel? For once, it's actually would be useful. You know, MSDN is usually good, but like anytime I've done ETW stuff, even a little bit, I always get frustrated with MSDN. Stack events. God, what is... Yeah, so this is what I even searched for Stackwalk. This is how undiscoverable this garbage is. Alright, so there's this GUID. Let's do this garbage. Oh, and this doesn't even have one of those NT-logger constants. Fucking Microsoft. Yeah, it's not even here, so I have to go and... Okay. What you will go through. And then I guess all of these. Okay, for now I just will I'll just make sure that it actually, that I didn't screw up that GUID definition. By printing something. And not to be crowded out, I'm just going to suppress these for now. Okay, so that GUID is actually in there, which is encouraging. So I'm going to leave this suppressed. Then we have to find the specific... I remember trying to, the first time I was reading this stuff and trying to make sense of like, is stack walk itself an event? It's like, no, it's just a GUID, but hey, but they're both classes, right? It's like, yeah, don't care about that. Oh my god. Okay, so this is the one. So this is 32 apparently. Let's just call it dot. Okay. I believe this one is a bit weird. So there is a timestamp, a process ID, thread ID, and then a bunch of pointers. Apparently there is up to 192 in the worst case. So actually we should do like this. Or even like this. Visual Studio is, it's like a, yeah, I guess it's a C99, right? Doesn't support that. Yeah, I think so. So the stack walk event is interesting because it's variable length. So apparently it can have, I don't know if actually 192 is like a formal limit. I don't think there is a formal limit. I believe ECW has a hard general restriction on event record size, which is 64K, which is very large. So yeah, I believe the way you have to figure this out is you have to parse the user data length. So this will get a little more intricate. I think you have to instruction pointer count. I think you have to take this, subtract off Well, it's also a question of whether they're aligned, right? I guess they would be, but if this is 64, I assume these are going to be aligned. So this would be 8, 4, 4. Yeah, okay, that does align. So I guess like this, and then divided by size of void star. Well, actually, let me just write out the size ofs to make it clear what I'm subtracting, actually. And let's see if that does it. Yeah, so this actually looks reasonable to me. Does it look reasonable to you? Like, there's some really shallow ones and something in the in the dozens, which is about right for a call stack. Some are only 2, but you're going to have threads that are only depth 2 if you have like a thread that just has a top level loop and no recursive functions. So I think that's probably actually. I guess it could be off. I guess this doesn't really tell you whether it's off by 1 or not. That's the danger. So we definitely need to go or off by more than 1, but off by some small number. Oh, they're all even. That's an interesting point. That is a very good point, sir. Use this timestamp to match the stack to an event. Okay. Yeah, that's a very good point. So what am I doing wrong? I mean, then it would almost be like I'm not dividing by the right number. Oh, I know what it is. It's because I captured it in 64-bit, but I was building on 32-bit. Good catch, sir. Thank you. That would have been a fun one to track down otherwise. All right, that looks better. Okay. Well, I mean, close enough, right? But that was a good catch. I'm glad we didn't have to go further to debug that, but catch it here. So that's why it helps to have viewers watching, I guess. All right, so I think basically I now want to. I guess we should look forward to what we're actually going to do. Should I allocate all of these? I'm thinking of how much to process in line. Yeah, let's just do them. Let's just allocate it, I guess. So this will be. So we're going to do this, and then we are going going to do a memcopy. Should put this in a variable because we'll need it for the memcopy as well. I mean, in this case, I guess I could just have, if I don't want to persist this stack walk event, I think I do want to persist the stack walk event, right? Because we can't do the all. I don't think doing all the aggregation along the way is probably easy. So let's just actually process it into our own internal in-memory format. I think that should be fine, even if it's maybe inefficient in some cases. Let's just do that for now. We can return to it later and see if there's a good way to aggregate sort of inline rather than batching, rather than recording everything and going back to it later. But so yeah, let's try to do this. So what were we copying from? We're copying from the user data, and we want this much data. No, actually, let's not. Let's wait with that for a bit. Let's just cast it for now. Check it out. All right, so I mean, I think this is already getting somewhere, don't you think? So right now we don't have we don't have this correlated with anything, but we could already actually, well, you kind of need to chunk things by function in order to do useful bucketing. You could do by thread bucketing pretty easily with what we have, but anyway, this is pretty cool. We should also be able to see a bunch of functions at the bottom of the stack that are identical. Like, I wonder if we search for this. Actually, let me also print out the thread ID so we can see which are. Actually, let me just stop printing out the depth. It serves its purpose to print that. And so I believe this is directly. Right, it's in the stack walk itself, actually. So process, let's see, timestamp. Timestamp. Process. By the way, if you want it to be dirty, we could do some temporary. Eventually, we're going to figure out things like process names by actually parsing the process events. But for now, I think we can just use some Win32 stuff, which should be okay in this case because most of the processes will still be alive by the time we get around to them. So let's get process name from ID. I think you have to do open process. Well, let's go look at MSDN. I can't remember all this shit. Print out the image names. Yeah, like I guess that's actually what I'm doing now. So maybe I'm ahead of you, or I'm reading your mind. Okay, I'm probably gonna use. I'm sorry. I'm gonna use some SDL because I want some quick and dirty, like maybe sets and maps. I'm not gonna use this for real probably in the final one, but I don't want to have to do redundant open processes. So basically, I want to have a because I'm gonna do a bunch of open process stuff. So if this is like I'll have a map from process IDs to handles, and oh god, I'll even use this stuff because who wants to type out nested SDL crap? Well, I guess if it doesn't exist, then we want to actually do something about it by calling open process with the process ID. Oh, a B tree? Yeah, that's true. But you know, I have pretty good confidence in my code, but I'm not sure how. I'm not sure I want to lean on it when I'm trying to write this. Let's see. Okay, desired access. So this is the query. I see. So desired access, inherit handles. So it's like something process query information. Okay. 0 process ID. If I guess we'll do this. If handle, let's just suppose this returns invalid handle value. So for whatever reason it failed, I'll just return this string. Otherwise we have to, we fill in, actually I guess I should fill in just the string because we don't need the process handle around. So let's call this process names. Well, let's see, what was the thing called? Get process image name. Receives the size. Is there a... Okay, so there's actually a path. So I guess image file name. Process image file name. Size of image file name. And then we're going to be lazy and just do this. Good old stirdup for maximum laziness and memory leakage. Oh yeah. Don't know what that was. Good old autocomplete that changes capitalization. What header is this in? Process API. Cannot convert from... Oh, I see. On this one. POSIX name is deprecated. Okay. Getting closer. So yeah, in theory now we should be able to just replace this by get process name. Well, actually, let's just call it not process name from ID, but just process name. And then let's try that. That looks like a memory overwrite. Oh no, actually not. It just has the full hard. I can't remember what you call this. Whatever the NTSC sort of internal path crap is, but so that did actually work. All right. So why did we get... I remember I saw some garbage. Did I not... I probably didn't check... Oh, I didn't check the return value. That's some amateur hour shit right there. What is the return value of this thing? It's a D word. So what does it return? So if the function succeeds, the return value specifies the length. Okay, so I don't care about the length because I'm going to use stirdupe. If this is 0, then we just return empty string as well. Let's just make sure that fixed it. Okay, that looks good. Some of the processes don't have names, but probably just means the name is super long. I guess maybe this is not like a normal path, so how long is max path? That's 256, right? 260. Maybe I should just make this like, I don't know, like a few K. Maybe 16K, which should be plenty and then some. I still get some processes that didn't succeed in this respect. But anyway, I mean, this looks broadly correct. I have some level of faith in this, at least. But anyway, the final way we'll actually be determining image file names, maybe I should just have done that so because I have to do it eventually, is by actually going to parse all the other events. So actually, that's a good exercise. I should do that now. So let's leave this in, but we need to go parse other events in order to make sense of all this crap. All right. So I guess I should go parse the various process events in order to do the stuff I just did the wrong way. Now the problem with oh, by the way, I can tell you why some of these processes were empty. It's because the process is exited by the point at which I actually parse it. So you have a lot of short-lived, like maybe this is the case here. You have a short-lived process. I get an event for it, a stack walk event. And then but only after the thing has been emitted do I go and parse it. In fact, probably like 10 seconds after. And at that point, the process is dead, so there's no match for this thing. So we'll be able to solve that when we go do things the right way, which is right now. But it means I have to go and somehow track down all these other shit events. Oh god, so it's like process, but it's not really process because there's a crap load of different process event types. man, this is going to be painful, isn't it? Oh, and these are all part of the same process GUID. So I need to go and get, at least I think the process GUID has a predefinition, so I don't have to go and do my own macro. Yep. Right. So I think I mentioned before of how both the start and end events have these sort of boundary or these sort of catch-up equivalents from when you start the session. Fortunately, these all look to be of this type, which is some sort of solace. I'm actually going to go and, well, okay, it's better if I spell it right. Sampled. Sampled profile. Event underscore sampled profile. Let's just do it this way. There's only a few occurrences. Because now we need event process. And for event process, there are 3 different events that share the same struct. There's this one. Start end, DC start, DC end. Missing. Oh. CCC has a pretty tall call stack. I actually think the reason it has a tall call stack is probably because of STL stuff. Now that doesn't make sense because the point at which it's doing that, I guess it could be because of message box being really crazy. Yeah. Once we get more resolution on what those pointers actually mean, we should be able to make sense of it. All right, let me just reconstruct this thing from the garbage C# crap. Unique process key. Oh yeah. The process key is because within a given trace session, it's possible for PIDs to be reused in theory. And this is assigned int. Okay. Directory table base. I think like that's a good directory table base. I guarantee you it's a pointer, but it's listed at UN32 unless you read the fine print. So, yep. I should go and read all these just to make sure I don't miss anything else. Full command line of the process. I mean, when they say full command. Okay, so these are actually null terminated strings. That's interesting. I was going to say that's no way that's possible, but I guess if those pointers are... I guess that must mean that when process trace does its whatever minimal pre-processing it does, it must actually do something for handle these, because obviously the pointers can't be pointers into the process memory since that's variable. So maybe this is some sort of convenience wrapper. Actually, it's also possible this is just bullshit, that actually the way I have to do it in C++ is completely inconsistent with this. Okay, let's go back to the top. Directory table base, user sid. Security, and this is, I don't even know what size this is. Like, how am I supposed to fucking lay out this struct? I guess we can try different things since we know there's some string data that will be garbage if we don't do it right. So, user sid. Let's make a wild guess that it's a, since it says object, I'm going to say it's a pointer. And this is actually image file name. And this is a command line. So unique process, process ID, parent ID, session ID, exit status, directory table base, user sid, image file name. Okay, looks like the right order. So let's okay, I'm just gonna pull this thing out before I lose it. Let's just output something to and actually I'm going to do the same thing I did before, which is just, you know, I'm just gonna, and actually I should leave this in, but I'm just going to put a return just to skip it temporarily because I don't want the output to clog up the output debug window. So let's just call this, let's just write like that for now. Okay, so we got a bunch of process events. Yeah, you're right. That's actually that's a really good idea. I just do this. And go and look in the trusty debugger. Oh, actually, let me do this. Event process. And now let me do that. Yeah, this doesn't look right. I mean, this looks like... This doesn't even... Well, let's see if we can open this in the memory view. Process image file name. And this looks, isn't this range like, I mean, this isn't even reserved, right, where we're looking here. Maybe, well, I guess let's say this is 64, maybe it's just misaligned because of that. No, I guess because of alignment that wouldn't really matter anyway, would it? Because it would round up to 8. I wonder, like, what else looks a little bit dubious here? Like, for example, that directory table base. I was going to say that's actually too low in memory to be a pointer, but I think for the directory table, you expect that to be low in memory, so this is probably good. So it's either that, I mean, this first thing does look like a pointer. It just doesn't look like, Let's think about this for a bit. Actually, you know what? It could very well be. Well, let's try something here. Let's look at the user data length. Let's see if that's variable, because I wonder, like the reason I was skeptical that they were string pointers when I read the description is that if you think about what has to be inside the event record itself, right? That thing has to live on disk and be serializable, so it can't have non-relocatable things like string pointers unless it's in the target process, in which case it's not very useful because I can't go read the target process after it's dead. So insofar as it's internal to that record, it somehow has to be like in there. So let's say process user data length. Let's see if this is variable. If this is variable, it suggests that there's something those docs are not indicating, which is that maybe there's some inline. If user sid is larger than your... What are you saying? Yeah. Let's try, yeah, maybe this could be something useful. Okay, I don't know why it's not copying the whole thing. Process, what was the other one? Process, command line. I mean, this does almost... Let me just check. I mean, let me just follow through on this thread. Oh, I see what you're saying. You mean maybe it's like an inline thing. Right. So yeah, let me just check the user data length and see if that's variable between records, and then we can do some arithmetic to figure out stuff. Okay, so that is variable. Oh, when... Okay, I think I know what they mean by this. It's zero terminated in line. So, in other words, like, first character is whatever this field is, I guess. I mean, that would be one interpretation. Actually, there's an easy way to look at that. Or there's an easy way to check that. I just have to cast the process pointer itself to a string. Oh, hasn't executed yet. No. That unfortunately doesn't look like a reasonable hypothesis. Oh, sorry, I have to... No, I already cast the user data. I mean, presumably this is also... Well, actually, let me try something for a sec. If I do... No. That's just garbage. That was a little bit of a weird hunch. Hmm. Actually, step one, I just realized something. Step one for me should be to make sure I'm only processing valid provider IDs or valid event IDs, because otherwise it's possible I'm actually using the wrong struct. So that's just me being stupid or careless or whatever. So let's not do that. Actually, let's just pick this one for now. Legal break because Visual Studio decided to auto brace in this annoying way. Okay. Okay, that's interesting. I didn't get any of those events. I guess processes maybe. I should do DC start because that thing has to get called at the startup. Oh, I should also actually control 10. Okay, here we go. Well, that is broadly the same thing. This is 67. This is a pointer. It's not. Actually, let me go and look at this process start, because they should have all the data in here. So they have user sid, which is before the command line. Let's do DC start. I guess that's maybe interesting. Is that it's totally possible some of these will have garbage, like PDC start. Like some of these don't seem to have. Yeah, in fact, if you look at these very first things, these are actually consistent with kind of what I saw. So maybe it's just the first few entries or like certain processes. Doesn't say pointer, so I feel like it's in line. Yeah, I agree, that seems reasonable. Let me just try one thing here. So if I do process, image file name, process, command line. Well, so one interesting thing is if I go and look at FF88, like that thing is like, what is that field? 1, 2, 3, 4. 1, 2, 3, 4. It's the stack base. Security identifier. I don't feel like a security identifier should be variable size. Um, what should I do? Let me just think about this for a sec. Well, one thing I can do is to see if there's actually, like, this is the ultimate cards method, but don't really care. ECW, or I guess process trace. Yeah, this is totally useless. So, actually, you know what? That user set has to be a pointer. I think the reason I say that is that this is actually C sharp. So when it says object, it means like object pointer, right? Oh, unique. Okay, I just found it, or at least one of them. Unique. This is why I hate this uint32 shit here, because some of these are pointers despite not seeming that way. So unique process key is actually a pointer. I don't know why it would be a pointer, because I would expect something like that to just be a like a numerical thing that's independent of the, but whatever. Let's try again. Okay, so this is starting to look more reasonable at least, or different. Now we're back to the same shit. I do feel like if this is object, it feels like it should be a pointer. But yeah, I definitely feel like, I mean, this was a definite mistake. Let's just check the rest of them, because now I'm paranoid. Command line is string, it's read only, it's zero termination. I still feel like if you do like process plus size of event process. I mean, there's some data here like idle. Okay, I think this is actually maybe the. So let me just do. I'm gonna do some F5 just to. Okay, that was very few. Another thing I just realized I should do is I should do a slightly longer capture. Yep. Do you see there's some stuff here? I don't know if it's the right stuff. Yep. 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 Do you see this shit? So there's definitely stuff and things after the end of the class. Alright, so we still have to figure out where that, like, why is that? So this thing is zero terminated. Actually, let me just, but why didn't I see that when I was looking directly at process? I see, so this is here, and then there's a zero terminator, and there's another thing. Yeah, so anyway, I mean, now I feel like it's just a question of figuring. I mean, I could actually get it just from the data here, just by hard coding the offsets. But I kind of want to figure out why. Like, what does this fucking thing mean? Like, is this actually an offset? No, that doesn't make sense. We looked at that before. Um, like these things, just numeric values. So what did I do here? So this was one past the end. And this is 1, 2, 3, 4. So it's almost like we're missing a 4-byte field somewhere. Like something that is... Maybe this is another case where there is a 32-bit thing that should be an 8-bit thing. God, this documentation is just garbage. Oh god, you know what? I do have another tool. The TDH parser. Do I have that on this machine? I do not. So was there anything I made smaller than it should have been? Session ID. Like for shits and giggles, suppose we just make, if I just put something here and then rerun. Oh, and the thing I wanted to do was actually, I want to do this because now I just want to jam. I don't know why I didn't do that earlier, but now that we have a trace, we should just jam on the same one so we have consistent data. Okay, so this is too far. Oh, I guess because of alignment, right? .exe. One, two, three, four. Okay, let me just try doing some stuff here. So I guess this is the image file name. Oh. Size of the value. Like this is interesting. This is mostly, but not always, something reasonable. Actually, let me just set breakpoints here. I want to see. I want to see when there's like bad string data in what way it's bad. I wonder what's going on is that um, maybe the other object is also variable length, but let me just find that. Okay, so this is a weird one here. Yeah, so I think that's what's happening. You can see in this case the task host.exe is quite a bit further beyond the normal offset, and it's probably because there's actually. So I think you're right about it being variable length, and actually, yeah, I think right. Like this is what it's actually like, right? Meaning there's a bunch of variable length stuff from this one, then there's a bunch of variable length null terminated stuff from those two strings. Okay, and I'm starting to see it. So now we just have to figure out what the variable length encoding of this thing is. Like maybe usersid is actually maybe usersid is actually. I mean, it looks like a pointer, so maybe like if we go and look at this and I don't think this points to anything in memory, does it? Hmm. Yeah. Okay, why does it? I don't know why this decides to do that. No, there's nothing here. This is not. I think this means map but not reserved, whereas these reverse video sections means unreserved. So usersid. I wonder if I'm even looking. Yeah, first two. I mean, let's try. I don't think this is going to quite work, but I'm flexible at this point. Yeah, that's not an actual length. I guess the other thing we could do is maybe that thing is zero terminated as well. So if we go and look at process again, or specifically look at, you know what, let me just remove this one just so I can use the size of the struct to indicate the end of the data that I know how to do something with. So if I type, I guess I can also just use the watch window for this particular thing. If I type process, try start process plus size of process. So process plus size of process. There's no sewer termination. Oh my fucking god. Thank you. Okay. Yeah. Let's try that. What's the return value? D-word. How is anyone supposed to fucking figure this stuff out, right? Good times. Let's see if this returns something reasonable. Did not. Probably who's, well, okay, let's see. psid. psid is just void. Oh, sorry, I should take the pointer of that thing. Sure. 500 seems excessive, but on the other hand, if it returns a value, I'm assuming it's valid. So, yeah. Alright. I think this is, I think we're there. So, let's try that. Yes! Okay, maybe not quite yes, but it works for some, well, it's suspiciously well aligned for some things. Maybe it's because I'm probably not checking the, like for the first one, it says, this was probably the one that was like 500. But let's check a bunch of cases. This is 500, 500, 500, 500. Why is it always 500? That's a ridiculous number. Now it's a power of 2. Well, actually, I should set the breakpoint below so I can actually see. Let's create some special watch window goodness here. So I want to see the SID length, and I want to see the corresponding image file name. This is an empty string, empty string. Maybe I need to do this. Let's try that for a sec. No. Definitely seems to be ASCII. The offset that we saw at the image file has. But the thing that's confusing about this is, like, let's just try to print it again. It's correctly printing a bunch of things. So I kind of want to know what those are. Like, what would be the easiest way to do that? I guess we could use conditional breakpoints maybe, which I never do, but why not? Why am I here? Why isn't... fuck it. I'm going to do it some other way. If image file name starts with... let's say couple B. Let me do this. This is how... Right, so look at this. This is really interesting. It's almost like... In some cases, I mean, that's too much of a coincidence, I would feel. I don't even know what function breakpoints are, honestly. I was just trying to find conditional breakpoints, which I never use. I always just do what I did here, which is just do my code changes and put a breakpoint within the if check. Yeah, I mean, it is very interesting. I mean, the fact that it's... Oh, I see. That's bizarre. Like, I don't understand why... I mean... I don't quite understand the idea that you would have a function like that return invalid data when you have a function to validate it. And you're like, go use that function to validate it. If you use this other function, things will be garbage. Actually, let me do this. Just and then we can use sort of some indenting to show it. Oh, opposite. Let's just verify that it still runs. Okay. I mean, that's interesting. So that says it's always invalid, even when I get a reasonable number back. No, this is definitely supposed to be. A pointer, I think. This is a pointer to a struct. Effectively, it's like a variable length struct. Well, actually, let's remove that for one. That was not, oops. That was not something I intended to be there. But yeah, so it looks like this valid is never actually passing. How big is it invalid? I mean, I can tell you actually, I know one way to solve this problem. So, okay, let me do it the workaround way, which is parsing everything from the back forward. So Um, so what's the second? What was the second field? Just put that in there so I don't forget. It was that one, and it was an all terminated command line. So this would be command line end. Command line end. User data length. Command line start. It's initially that. And then I guess that won't necessarily. I mean, that won't give us the. Well, let's see if the other one is not terminated. I think that's a little bit of a. Eh. This could continue into well into previous parts, but let's see that. Image file name start. Actually, let's just call this command line. The image was ASCII and the command line was wide. Alright, that's good to know. I guess that means I have to, yeah. Well, but if I'm doing this stepping, it's almost like I have to do it like that. I can't remember enough UTF-16 to remember if I can even do this then. Like, because I can't obviously use... Okay, let me just look at the memory layout again. One sec. Yeah, man, this shit isn't working, but let's just try to see this here. Okay, that's not what I want to do. I should go really just Google some stuff and see if there's actually some precedents for this. Um, like, for example, if I can find... Hmm. Okay, there's also another way entirely, which in theory would work here. Ooh. Ooh. Okay, this seems a little weird. I don't know if I trust this. Although it kind of lines up. Is it really? Okay, I'm willing to try this. I mean, the number 13 is a little too specific. Yeah, I agree it's 13, but I don't know. I'm desperate. I mean, he's presumably actually using it. Like, does he actually print the image file name anywhere? Okay, I'm willing to try this if you... And you're right, the other one is WTAR. Okay, so... yeah, you have image file name as the first thing here. And then you have, after that, in spirit. What is he saying? Yeah, after the image file name, plus Sterling. Mm. Oh, so do this bytewise, and then yeah. I don't even know what's going on here in terms of the... Like, why is it not printing more? Maybe it's just because it's so much garbage. Yeah, it's so much garbage data that it's probably just shitting itself somehow. Yeah, so you're right. They can't. Okay, let's look at this. Well, I mean, this guy doesn't seem to do a whole lot. Type group 1, SID. macro for determining the length of a SID. I don't even know where that comes from, but oh, there's a struct here. Okay, I don't know why I didn't see that struct earlier. My fucking god, are you kidding me? Are you kidding me? Jesus. I mean, that's somewhat my own fault, I have to admit. Get length in, okay. Okay, that didn't work, but I feel like we're getting there. Yeah, I assume the way this works, by the way, and this makes perfect sense, is that the SID has probably like a fixed header and then, you know, some variable length thing beyond that. I'm actually just going to use this because I now trust that guy. Um, okay. Well, I guess maybe step one is actually just now that we have a type for the SID, we should just go and look at it in the debugger to see what it says. That's not what I intended. Well, I would say the thing that's encouraging is that these fields are constant. And the sub-authority, which points to something. I mean, and the interesting thing is I'm still getting back 500. Let's put the brief one on this line instead. Okay, so I think 36 was usually when things were better. Um, maybe the SID length is actually beyond the struct itself. Haha. I'm seeing a lot of constant image file length names. Okay, that's not encouraging. No. Okay, that was a fluke. Yeah. Hmm. Define to large sub-authority count explains. Yeah, I guess that. Oh my god. I mean, this stuff is so poorly documented and fucking opaque. This is actually use UTW? Oh, it does. You know what? I should just read this and stop trying to thrash around. Let's see how they use this. Where do they get the PSID for? Hmm. Yeah, I guess so I've done TDH stuff before. That's like the trace helper data API. Maybe I should use TDH. TDH is sort of a way of, I guess it's kind of like a reflection system essentially. Um, but if you're dealing with a closed set of types, like I am, ideally you would just do it using like manual uh, address arithmetic rather than having to go through this heavyweight crap. Yeah, I really don't want to do that. There is definitely a way to do this crap. Hmm. So what was the logic here? We take the sub-authority count. Wait, this is pretty inscrutable. So where does this bracket go? I see. Okay, so you find the sub-authority. So you find the sub-authority count, multiply by 4, and add 8. So presumably 8 accounts for the fixed fields. So 1, 2. How big is this thing? I see. 1, 2. Okay, so there's 8 bytes for this common header, and then there's a variable number of bytes here. In theory, that should be straightforward. I feel like in some sense this is actually correct, and even the 500 is maybe correct. So maybe there's just something else. Like, yeah, so first off, I definitely should do it off the base, based on what I just read there. I should definitely do it this way. Do it off of the base address of the SID itself. Which I think I already did, but let's just try it. Yeah, the SID is actually complete. I didn't even know what a SID was before today, and I've been leading a happy life, mostly. This is not good programming stream material. This is like watching paint dry. It could be that, let's see, 1, 2, 3, 4. Okay, so there's not a weird thing that could cause alignment. Let me go and read the struct again about the ordering. Unique process key, process ID, parent ID, session ID, exit status, and then a pointer, and the user SID, and then image file name and command line. Right, command line is wide. This is ASCII. I guess I'm confused about why when I did this originally I got some data that was useful. Like, I feel like when I did this, or like, I think I did this, but I guess it doesn't really matter what I do for that. Let me even use the exact function. So it was get length SID. It was like process. Could have sworn I got useful data when I did that originally. Also, I really should go and look at, in fact, I'm stupid for not having done that earlier. I should go and look at these. Because you'll note that I think a bunch of them, well, PDC start some of them have this unknown thing. So, and now we get a command or an image. Hmm. So address of the user ID, bytewise, offset. I mean, the thing is, look at how few bytes are changing in this section between um, between the different runs. It really does suggest that there's like most of the action is out here, for example. So I wonder if it's like if I go 8 bytes back and then look at 100, is there anything interesting? Hmm. So here we seem to be in the AMSER. This seems to be UTF-8 in this area. So let's go back. Still looks like UTF-8. Or UTF-16, I don't know if I say UTF-8. It doesn't make sense though. So in this case, it's like we're catching the middle of the string. But it doesn't even have to be that string. It could be something else entirely. So, I mean, we do have just like a big event trace, like all kinds of data is just laid out linearly. This is arithmetic, not right. I'm probably going to turn off the stream in a sec because this is the kind of bashing the head against a wall on a stupid specific problem that is easier to do if I go for a quick walk or something. So anyway, thanks for hanging out. I'm sorry. Hopefully there's some interesting info earlier in the stream. Right now, I mean I could do an end run around this problem temporarily, but I actually think I'll run into this elsewhere. So I need to figure out how to deal with it. If any of you follow me on Twitter, I'll post the resolution, and I plan on doing more streaming for the profiler probably tomorrow and over the weekend. So thanks for coming around, and thanks BSVino for the over-the-shoulder bug catching. That's good stuff. I appreciate it.